Good morning to one and all. This is Dr. Y.V.N.R. Swami, Associate Professor in the Department of ECE. In the last class, we discussed about Coulomb's law and electric field intensity. Okay, Coulomb's law states that the force between 2-point charges Q1 and Q2 is along the line joining them directly proportional to the product of 2-point charges Q1, Q2 and inversely proportional to the square of the distance r between them. Then F is equal to Q1, Q2 by 4 pi epsilon naught r square along AR direction, because force is a vector, has magnitude as well as direction, where A suffix r is a unit vector whose magnitude is unity. Okay. In the same way, electric field intensity. The electric field intensity is defined as the force per unit charge. Unit charge. So that is F equal to E by Q, and electric field intensity due to point charge is F is equal to Q by 4 pi epsilon naught r square along AR direction. So here AR is a unit vector whose magnitude is unity. So based on these two formulas, we are going to solve problem in this class, in this lecture. Okay, so now we will start that one. So this is the problem. So see the problem. The point charges 1 millicoulomb and minus 2 millicoulombs are located at 3, 2, minus 1 and minus 1, minus 1, 4 respectively. Calculate the electric force on a point charge. Electric force on a point charge 10 nanocoulombs located at 0, 3, 1 and the electric field intensity at that point. So here given data, 2-point charges are given. Those are Q1, Q2, 1 millicoulomb and minus 2 millicoulombs. 1 millicoulomb is located at 3, 2, minus 1 point. Minus 2 millicoulombs are located at minus 1, minus 1, 4 point. So now we are going to calculate the force and electric field intensity at the point charge, at the charge 10 nanocoulombs. That 10 nanocoulombs charge is located at the point is 0, 3, 1. 0, 3, 1. Okay, so that is the given data. 2-point charges are given at located at points. Now we are going to calculate the electric force and electric field intensity at a 10 nanocoulombs point charge that will be located at 0, 3, 1. Okay, so first of all, we have to mention this is the point charge Q1 and this is the point charge Q2. Point charge Q1 and point charge Q2. Okay, so now coming to this one, these are the 2-point charges Q1, Q2. We are going to find the force and electric field at this point charge Q equal to 10 nanocoulombs. Okay, at this point. So now you have to make from point charge Q1 to point Q, the distance will be represented with R1, and the point charge Q2 to charge Q will be represented with R2. So for these 2-point charges Q1 and Q2, you have to find the force F1, and for point charges Q2 to Q, you have to find the force F2. And then you have to add these forces F1 and F2, or we have a force formula for n number of point charges. What is the force formula for n number of point charges? F is equal to Q by 4 pi epsilon naught into sigma k equal to 1 to n. qk by r square along AR direction, where AR is a unit vector. Here, how many point charges are there? 2 point charges are there. So, q1 and q2. So, now we will write F is equal to q by 4 pi epsilon naught into q1 into a suffix r1 by r1 square plus q2 into ar2 by r2 whole square. R2 whole square. So here we can modify this formula one more way also. F is equal to q by 4 pi epsilon naught into q1 into r by mod r whole cube, r1 by mod r1 whole cube plus q2 into r2 by mod r2 whole cube. Whole cube. So now we are going to find the vector r1, r2 and magnitudes of vectors mod r1 and mod r2. After that, we have to substitute those values in this formula. Then we will get the force. If force is obtained, then electric field intensity is force per unit charge. Unit charge. Okay. So now, first of all, we are going to find the vector R1 from Q1 to Q. Okay, Q1 to Q. So what happened? R1 is equal to 0 minus 3 along AX plus 3 minus 2 along AY plus 1 minus of minus plus 1 along AZ. So then what happened? This step. So here 0 minus 3 minus 3 AX, 3 minus 2, 1 AY plus 1 plus 1, 2, 2 AZ. Then what is the magnitude of the vector? Square root of 3 square 9 plus 1 square 1 plus 2 square 4. So root 4 is the magnitude of the vector R1. In the same procedure, in the same fashion, we are going to find the vector R2. Vector R2. So that is 0 minus of minus plus 1 AX along AX, 3 minus of minus plus 1, 3 plus 1 along AY, 1 minus 4 along AZ. So then what happened? 1 AX plus 4 AY minus 3 AZ. So then what is the magnitude of the vector R2? Equal to square root of 1 square 1 plus 4 square 16 plus 3 square 9. Root 26 is the magnitude of the vector R2. Now substitute these values in this formula. Okay. So therefore F is equal to q by 4 pi epsilon naught into q1 into r1 by mod r1 whole cube plus q2 into r2 by mod r2 whole cube, that is equal to q by 4. What is the q value? Q value is given, that is 10 nanocoulombs. 10 into 10 power minus 9 into 1 by 4 pi epsilon naught value is 9 into 10 power 9. Then q1 is equal to this one, 1 millicoulomb, 1 into 10 power minus 3 into R1. R1 is this one, minus 3AX plus AY plus 2AZ by mod R1 whole cube, that is 14 root 14 plus Q2. Q2 is minus 2 into 10 power minus 3, 2 millicoulombs into R2. R2 equal to AX plus 4AY minus 3AZ by mod R2 whole cube is 26 root 26. Therefore, by solving all these things, 10 power minus 9, 10 power plus 9 will cancel. Then 9 into 10. So in these two terms, 10 power minus 3 is common. Okay, into these two vectors minus 3x plus ay plus 2az by 14 root 14 plus minus 2ax, 2 into multiply this one, minus 2ax minus 8ay plus 6az by 26 root 26. So, after calculating all these things, we will get the force F equal to minus 16.507 along AX minus 3.817 AY plus 7.506 AZ millinewtons. This is the force. This is the force at this point. Force at this point. Okay. So, in millicoulombs. Now we will find the electric field intensity. We know that electric field intensity is equal to force per unit charge. Force per unit charge. So then E equal to F by Q. E equal to, what is the F obtained in our problem? F is equal to minus 6.507 AX minus 3.817 AY plus 7.506 AZ to millicoulombs, 10 power minus 3, 10 power minus 3 by Q. What is the Q? Q equal to Q value 10 nanocoulombs. Q is 10 nanocoulombs. That is 10 into nano means 10 power minus 9. So then after solving this one, we'll get E equal to minus 650.7 AX minus 381.7 AY plus 750.6 AZ. So kilovolts per meter. The units for electric field is volts per meter or newtons per coulomb. So that is electric field. The obtained electric field intensity is minus 650.7 AX minus 381.7 AY plus 750.6 AZ kilovolts per meter. Kilovolts per meter. This is the obtained electric field intensity. Okay. So in this way, we are going to solve the electric field intensity as well as force. If force is obtained, then we will calculate the electric field intensity by using the formula force per charge, F by Q. Okay. So this is problem based on force and electric field intensity. Force and electric field intensity. Okay. So in the same fashion, you can solve one problem. This one, point charges 5 nanocoulombs and minus 2 nanocoulombs are located at 2, 0, 4 and minus 3, 0, 5 respectively. Now determine the force on a 1 nanocoulomb point charge located at 1, minus 3, 7 and find the electric field intensity E at 1, minus 3, 7. In the same fashion, what we solved in this lecture, in the same fashion you can solve this problem. Okay, I hope force according to Coulomb's law and electric field intensity topics are clear. In the same fashion, the problem is also clear to you based on previous topic. Okay, thank you.